Today, we are going to be looking at functions. And a function is a relationship where one thing depends on another. That is what we call a function. Okay, so here we have our little function machine, what we put in and what we get out. What we put in is called the independent variable into the machine. That is also our input. And that is also our x variable. What we get out of the function is our dependent. Our output is what we get out of it. And it is also our y variable. So let's look here at our first example. Suppose you earn $5 each week. Make a function table for that to show your earnings for 1, 2, 3, and 4 weeks. So it tells us that the input is our number of weeks. Remember, that is going to be our x variable, our independent variable. And our output is going to be our y variable. It is going to be the money. What we get out at the end is going to be how much money we spent. So we need to come up with a function rule. So we can think back to our writing equations last week. $5 per week, each week. So our money, the y, our total money equals 5 per week. We learned that was multiplication. 5 times our x value over here. So now we can plug in. We're looking for weeks number 1, 2, 3, and 4. So now we can plug in our number of weeks to figure out how much total money we have made. So our total money equals $5 for just 1 week. At the end of 1 week, 5 times 1, I have made $5. After 2 weeks, we plug our x value in. Our total money equals 5 times 2, our x value. 5 times 2 is $10. At the end of 2 weeks, we have made $10. For 3, we plug our 3 in for our x value. Our total money y equals 5 times the 3 weeks we have worked. 5 times 3 is $15. At the end of 3 weeks, we have $15. And for our last week, we plug in 4 for our x. Y equals 5 times 4. $5 a week for 4 weeks. At the end of 4 weeks, I have made $20. So our input, our x value, is what we plugged in. This was our time. Time is always going to be our independent variable, our x, and money most often is our output. Now we have a couple more vocabulary words here. The set of input values is the domain, and the set of output values is the range. So let's look. In the example 1, the domain is what? Well, the domain is the set of input values. So here is our domain. It is our x values. Our domain was 1, 2, 3, and 4. It is all of the x values we plugged into the equation. We put it in. The range is the answer we got out. The answer we got out. This is our range. Our range was 5, 10, 15, and 20. So we put in the number of weeks, that was our domain, and we got out our total earnings, that was our range. Now, since we have x and y, we can make each of these an order pair answer. So for week 1, I made $5. For week 2, 2 weeks, I made $10. Remember, X comes first, Y comes second. For week 3, if I've worked 3 weeks, our X, I've made $15. And lastly, 4 weeks, I made $20. So we can turn each of these into an order pair, which is a solution to our statement. So now we're going to try another example. So let's look at another example here. We have a function rule, our independent variable, and our dependent variable. Remember, independent variables are always going to be the X. It's what we're going to plug in, our input. Our dependent variable is what we're always going to get out. It's our output. And it's always going to be Y. A way to remember that is to think, why don't I have a pencil? I depended on Miss Millen to give me one. Why don't I have my packet of notes? Because I depended on Miss Millen to give me an extra one. So why don't I have to drive to school? Because I depend on my mom to take me. So that's one way to remember that Y is our dependent. So now that we have our two names here, input, independent, what was the third name for our X values? Well, our X values, the third vocabulary for those are domain. And we have two of our Y value vocabs, output, dependent. But what was the third word? Range. Remember, X goes by input, independent, and domain. And Y goes by range, output, independent. Good. So now we can plug in and find the solutions for our function. So we take our X value, our input, our independent, and plug it in to our function rule. So now I know Y equals -2 plus 3. My signs are different, so I subtract to get 1. And then I write my solution as an ordered pair. X comes first, Y comes second. And I continue to do this. I take my -1 now and plug it in for where the X is. -1 plus 3. My signs are different, so I subtract. And I write my final answer as an ordered pair. X was -1, 2 is my Y. I plug in my 0 now, my next X value. Y equals 0 plus 3. I get 3. When X is 0, Y is 3. And I keep plugging in to this same function rule. Well, what if X was 1? Well, 1 plus 3 is 4. So if X is 1, Y is 4. And my last X value I plug in. Y equals 2 plus 3. 2 plus 3 is 5. When X is 2, Y is 5. So now it says, let's graph these solutions. Let's graph these solutions. So remember when I'm graphing, the horizontal line here, this is my x-axis, and the up and down vertical is my y-axis. So if I graph my points, I got to go to x first, and then y. I got to go into the house, then up the stairs. So I start at 0, 0, and I move over -2, so 1, 2, and then go up 1. There's my first point. Then I moved on to my next one. I go over to -1 and up to 2. Then I stay at 0 and I go up 1, 2, 3. Then I go over to +1 and up to 4. 1, 2, 3, 4. And my last one, I always start back at 0, go over 2, and then up 5. 1, 2, 3, 4, 5. And I can extend my line straight through, connecting the dots. I have now graphed my solution. This is what we call a linear. If it's linear, it means it makes a straight line. Now, so this is linear. It is straight. What will the y, the dependent, the output, the range, be if x is 7? So I still can use my same function rule. Y equals x plus 3. I plug in for 7 for x. Y equals 7 plus 3. So we got 10. So y would be 10. And how did we figure it out? We used the function rule. Good job. We can also, if I extend my line all the way to keep going, we can also use the graph. If we graphed accurately, go over to 7. If x is 7, where does it cross? It crosses at 10. So we could also use the graph to pull off that point that when x is 7, y is 10. 7, 10. Good. So let's open up our page. And we're going to try another rule together. All right, so we're going to look at number 3. It says complete the table and then graph it. So that's what we're going to do now. So if we look here, let's think about our vocab words for a minute. Remember our x values here. Our x values have 3 names. It's our input, it's our independent, and it's our domain. And our y also has 3 names. It's our output, it's our dependent. Why don't you have a pencil? You depended on Miss Millen. And it's our range. So there are our vocabulary words. But that was just a review. We don't really need those to know how to plug in. So we take our first x value and plug it into our function rule. Y equals -2 minus 3. Y equals -2 minus 3. Keep, change, opposite. A -2 and a -3 make -5. -5. So when x is -2, y is -5. Then we plug in our next x value. Y equals -1 minus 3. -1, keep, change, opposite. -3 and -1 is -4. So when x is -1, y is -4. Now our next one, 0. If I plug in 0, y equals 0 minus 3. 0 minus 3 is -3. When x is 0, y is -3. Let's try the next one. I plug in y equals 1 minus 3. 1 minus 3 is -2. 1 is x, then y was -2. And our last one we plug in, y equals 2 minus 3. 2 minus 3, keep, change, opposite, is -1. So when when x is 2, y is -1. Now it says we have these order point solutions of our function rule. Now we can graph our function over here. Remember, this is the x-axis and this is the y-axis. You must always do x first, then y. Got to get into the house, then up the stairs.